Okay, the last thing about the rational root theorem. Let me explain it by an example. Okay, this is our polynomial we want to factor. We factored it before, but here I want to give you an easier way. Let's call it f of x. According to the remainder theorem, I talk about it first in the how to factor crazy polynomials. Why polynomials 1, the first videos of the how to factor crazy polynomials, and I proved it in the video after that, the remainder theorem, which says that if a number make the polynomial equal to 0, let's say the number is a, then x minus a is a factor of the polynomial. So here, if a makes it 0, x minus a is a factor of it, and this would be equal to x minus a times g of x, another polynomial. Okay, and this is helpful. How? According to the rational root theorem, in order to factor this, one way is trying and substituting the divisors of 60, the constant term. Okay, we did that before. But according to this, we do not have to try every single divisor of this. How? For instance, suppose we tried and substitute the plus and minus 1, and we saw as before that doesn't make it equal to 0. So how about plus 2, the next step, the next number we should try? Okay, and here, instead of substituting 2 into this, check this out. Okay, here we want to know if 2 makes it 0 or not. So if 2 makes it 0, then this polynomial should be equal x minus 2 is a factor of it, and it should be equal to x minus 2 times another polynomial. So now this is true for every values of x, this relation. Okay, easy. So then it should be true, or this relation should exist for x equals minus 1. Let's substitute minus 1 here. That means f of minus 1 equals to minus 1 minus 2 g of minus 1. Okay, what is it? This is minus 3. divide both sides by minus 3, and this would go away. Let me g of minus 1. Okay, now the coefficients of this are integers, so f of minus 1 is also an integer. Okay, and the coefficient of this is also an integer. Why? Because the coefficient of x here is, what is g of x? G of x is f of x divided by x minus 2. If you do the long division, write f of x here divided by divided by x minus 2. Every term of this divided by x, because the coefficient of this is 1, would be also an integer. Okay, so the coefficients of g is also integers, then g of minus 1 is also an integer. That means that f of minus 1 should be divisible by 3 or by minus 3. So let's check if it is true here. What is f of minus 1? Is minus 1 minus 10 minus this plus this. Okay, this is minus 3, this is minus 11, and it is not divisible by 3. Then plus 2, we found the number which is minus 1, which doesn't satisfy this relation, which means that this relation is not exist for every values of x. That means that x minus 2 is not a factor of f of x. Okay, we, without substituting, just found out that x equals plus 2 doesn't make our polynomial vanish. And it is mostly useful for the the bigger divisors. For instance, we have to calculate some, for instance, f of 1, what is f of 2, what is f of minus 1, f of minus 2. In order to, for the bigger divisors of this, for instance, how about plus and suppose we got a polynomial with this constant term, but none of its divisors to minus 5. We start substituting from plus and minus 1 till minus 5, plus and minus 5, and none of this made it equal to 0. So then the next divisor is 6, for instance, in x minus 6 times g of x. And here, for instance, we could substitute 3 here and see if f of 3 is divisible by 3 minus 6, which is 3, or we could substitute 2 here and check if f of 2 is divisible by 2 minus 6, which is minus 4. Okay, that's it.